Second part of aggregate, the discussion is to learn about the properties of aggregates. Several properties such as toughness, the strength, and durability, and a lot more of aggregate properties we will discuss. And what is the most important for aggregate is the aggregate must be clean, hard, and strong. In the meaning of strong is must be well graded. And the best aggregates is the one with good particle shape, good surface texture, and those aggregates will not react chemically with cement. In terms of abrasion resistance, it is essential when aggregate is used in concrete subject to abrasion, for example floors and pavement, and also having chemical stability. The best aggregate include those who have the resistance to freezing and thawing, and also have good compressive strength. So in details, what you need to know under the properties of aggregates, including strength, hardness, toughness, durability, porosity, and also water absorption. So in discussing strength, that aggregate should be in the range of 70 and 350 Newton per mm squared. Good aggregate is at the range of 200 Newton per mm squared. This is what we consider as good strength. How to know that the strength of aggregate is good? It must pass the aggregate crushing value, aggregate impact value, and that aggregate also have only 10% fines value. In terms of hardness, that aggregate should withstand load, and the hardness is depends on parent rock, and how to test for hardness is from abrasion test. For toughness, the meaning of toughness is the failure by impact. So this one must be from external impact, so the aggregate must withstand the aggregate impact test. For durability, this is also from external and internal factor. What we consider under durability is the damaging attack from external and internal attack, and this is also known by soundness. And how to test is because of we need to know what is the effect of the aggregate to creep and also shrinkage. For porosity is something that you need to know how that aggregate can absorb water when dry and then release when wet. So it depends on the size of the particle of aggregates. So the bigger size, it is more porous. So if the the mixture is compacted well together, it is less porous. And for water absorption, it is the water absorbed by oven dry aggregates in reaching saturated and surface dry condition. It is by observing the water absorbed by oven dry aggregates in reaching saturated and also surface dry condition. So that is all about the properties of aggregate. And next is the particle shapes and surface texture. This is also important to determine the performance of the concrete mix. The property of concrete, mobility of fresh concrete, and bond between aggregate and mortar paste. So the shape is divided into several shapes: flaky and elongated, rounded, irregular, and angular. So based on the picture, this is what is the flaky means. It is a material of which the thickness is small relative to other dimension. This thickness is small, this dimension is bigger, and this is also the dimension is bigger than its thickness. And the example for flaky shape is laminated rock. Next is elongated. The aggregate usually angular is shape and the length is considerably larger than the other two dimensions. For flaky and elongated material having the length which is considerably larger than the width, and the width is considerably larger than the thickness. So next we have this rounded aggregates. The picture shows exactly what is rounded aggregates looks like. It is full water worn, completely shaped by attrition or abrasion. The example for this kind of aggregate is from river or seashore gravel. And this is kind of a mixed shape of aggregates. Some of the aggregates is bigger, some is smaller. So this is irregular shape, naturally or partially shaped by attrition and having rounded edges. It can be from natural occurrence and it can be from the factory. You get this kind of aggregates. The example for this shape is gravel land and dark flint. So for angular, this is almost kind of manufactured aggregates. It is a processing well-defined edges formed at the intersection or roughly plane faces. And of course, this is from crushed rocks of all types of rock. Okay, next is the surface texture of aggregate. This is also important for the concrete performance. What is surface texture? It is the measures of smoothness or roughness of aggregates. When you have concrete mixed with aggregate with high roughness, the strength of the concrete will be higher. To compare, if you mix the concrete with smooth aggregate, the strength of the concrete is lower. The strength of the bond development of mechanical anchorage between aggregate and cement paste depends on surface roughness and surface porosity of the aggregates. Let's see this one. If we have rough aggregates, the texture increases the aggregate cement bond by 1.7 times. So it's okay for us to have high roughness. This will increase the performance and also increase in compressive and flexural strength up to 20% to compare with using the smooth surface aggregates. Aggregate with polished surface do not produce strong concrete compared to those with rough surface. Okay, the roughness give the extra performance in contact with your cement paste. So this is how the classification of roughness. This is high roughness, more than 750. And if we polish that aggregate, it's like kind of look like this one. The roughness is less than 200. So the classification is based on high roughness, moderate roughness, low roughness, smooth, and polish. So next is to know about grading of aggregate. We need to grade the aggregates using sieve analysis test, and it is the quantity of material representing the bulk sample is carried out by quartering by hand, refill box, and sampler splitter. Okay, why we need to do the grading? Because of it has effect on workability and stability of concrete mix. Aggregate of uniform size, compacted mass will contain more voids because of the uniform size. But aggregate of various size, compacted mass will contain lesser voids. So if you compact the same shape of aggregate with the concrete mix, this is what it look like. It is more porous or more voids. But if you have different size of aggregates, all the spaces will fill up with those aggregates. That is why in concrete mix we have both cost and also find aggregates to avoid the void. So proper grading produce dense concrete and need less quantity of fine aggregate and cement paste, and it also produce less segregation. At the end, it also affect the performance of the concrete mix. So that is the second part. Next we will discuss under other discussion for aggregates.